Okay, welcome to the November 23 paper 2H walkthrough of Edexcel's 4MA1 series. The modal class, question 1, most frequently occurring, where 18 is the largest number on that list, and that's between 25 and 30. For part B, it doesn't want a mean, it wants the total length, so don't be tempted to divide by 50 at the end. Just multiply the midpoint of each of the intervals by its frequency for each one of those. Add them all together, you get 945 minutes for our estimate of the total length of all of the calls. Question 2. First, I'm going to work out BC by using Pythagoras. So the square root of 10 squared minus 8 squared, and that tells us that B to C is 6. Therefore E to C is going to be 5 plus 6, which is 11, and W we can do Pythagoras again. This time we have the two shorter sides, so we'll square and add, and then square root comes out to 17.8. Question 3, reflection in the line y equals x. Do a little line there for y equals x. And then I'm just going to do a few points, reflect a few points in that line. And you can see where they come out, and you'll see the shape starting to form. And then we'll do a little dot to dot. I'd probably use a ruler if I were in an exam doing this. And there we got a new shape. The transformation, A to B, well, it's an enlargement, 1 mark, it's a scale factor 3, 1 mark, and the centre of enlargement is at 7, 2. You can draw lines going through each of the corresponding vertices, and they'll all meet at 7, 2. Question 4. Solving the equation, multiply both sides by 6 to start with, bring the x's onto the right and the numbers onto the left. You could do it the other way around and then get lots of negatives that cancel. Divide both sides by 10, x is 3.5. For B, h to the 12. For C, 16, g to the 12, k to the 20. For D, I'm going to write these as a single power of y on the left, because the 5 plus the n will take away the 7 because it's at the bottom, is equal to y to the 12. N minus 2 equals 12, so n must be equal to 14. Question 5, the ratios question. Flour to butter to sugar. So we've got 6 to 5 as the ratio of flour to butter, and then 3 to 2 is the ratio of butter to sugar. So the lowest common multiple of 3 and 5 is 15, so I'll make the number of parts of butter being 15. Therefore flour will be 18 and sugar will be 10 from the two other ratios. So we take 120, divide it by 10, times it by 18 to work out the amount of flour. It comes out as 216. For the fractional division, just be careful, it's a show that question, you must show every step. Writing them as top heavy fractions, flipping the fraction we're dividing by and multiplying. Cross cancelling, absolutely fine as long as you show that you are cross cancelling. If you haven't and you've cancelled later on, that's absolutely fine too. 9 over 7, and then that is equal to 1 2/7. Question number 7, Hermione and her boat. Depreciation by 8% is the same as multiplying by 0.92. It's finding 92% of an amount. Cube that to get 20,869 when multiplied by 26,800. Question number 8. So the mean number of goals scored by the team in 8 matches is 6, so the total number of goals is 8 times 6, which is 48. After the 10 matches, it's 7, 10 times 7 is 70. You can do this in a number of ways. You can find the difference and halve it, set up an equation and solve it, whichever method you prefer. K comes out as 11 if you've done it correctly. Question 9, coordinate geometry. The gradient, we've got y2 minus y1 over x2 minus x1. Comes out as 3 over 2. We can see from the point 0 minus 3 that the y interval is minus 3, so the equation of the line y equals 3 over 2x minus 3. Any equivalent equation would be fine. Question 10 is a compound shape. I'm going to draw a dotted line to split it up into a rectangle and a trapezium. That line length is 17 because A to B is 25 and D to C is 8. So the value of x, we're going to come up with an expression for the area. The area of the rectangle is 25 lots of x plus 2, and then the area of the trapezium, half the sum of the parallel sides times the distance between them. Do this and you will find the area of a trapezium. So half of 17 plus 7 times that by 4, sums to 258. All we have to do now is solve the equation. So expand everything out, and then collect the like terms or any constants here, divide both sides by 25, we get x equals 6.4. Question 11, the probability question. It's going to be 11/16 for not red, and then from box Y we've got 7/20 and 13/20 for both of those. And then for part B, 2 reds or 2 not reds. Well, the 2 reds require it to be red and red. The 2 not reds are not red and not red. So 5/16 times 7/20, 11/16 times 13/20. And then add the 2 together because we don't mind which one it is. It's an all one. Comes out as 89/160. Question 12, these are, well, 4 is the power of 2, so I'm going to rewrite 4 to the power of 5 as 2 squared to the power of 5, which I'll simplify as 2 to the power of 10, and for the right hand side, 4 squared to the power of x, 2 squared to the power of x is 2 to the power of 2x, add the powers, 2 to the 17 is equal to 2 to the 2x, so 2x is 17, x is 8.5. For part B, to the power of 2/3, you can plug these on your calculator or cube root and square, it's up to you. 25, p to the 4, y to the 16 is the correct answer for that one. Question 13, 11 bits of data, the median's at 6, the lower quartile's at 3, and the upper quartile is at 9. Difference between the 3rd position and the 9th position is the difference between 13 and 4, which is 9. Question 14, we can rearrange the top equation to y equals x plus 2. I have miswritten that as 2x plus 2, but I've drawn the correct line that intersects at minus 1, 1, which is the correct answer for that one. For question 15, so the algebra trick for turning a recurring decimal to a fraction. We'll let the recurring decimal equal to x. I'll bring the recurring bit up to the decimal point by multiplying both sides by 10. Then we have 2 recurring numbers, so I'll multiply both sides by 100. And we can find the difference between 1000x and 10x. That would be 990x. 372 minus 3 is 369. Divide both sides by 990. We get x equals 369 over 990, which simplifies to 41 over 110. Don't shortcut on that one, it's a show that question. For B, it also says show you're working clearly, so there's lots of chances to lose marks here. 125, I'm not going to jump straight to 5 root 5 because it's asked me to show my working clearly. I'm going to rewrite 125 as root 25 times root 5, and similarly root 80 is root 16 times root 5 all over root 3. That simplifies to 5 root 5 plus 4 root 5 over root 3, and then collect the root 5's together on the numerator, so we get 9 root 5 over root 3. Let's rationalise the denominator, so I'm going to multiply by root 3 over root 3, gives me 9 root 15 over 3. The 9 over 3 can cancel to make 3, so our fraction becomes just simply 3 root 15. 3 is the same as the square root of 9, so I'm going to rewrite 3 as root 9. Root 9 times root 15 is root 135, which is my answer for that one. Question 16. Pick any two and multiply them together. I'm going to do the first two. 2x squared minus 7x minus 15 times by x plus 4. Then you can expand these out one at a time and collect like terms. I've expanded and then just collected them as I've gone along. 2x cubed plus x squared minus 43x minus 60 is where you'll end up if you've managed to do it correctly. Question 17, upper and lower bounds question. So A is 8.3 correct to 2 sig figs, so the upper bound for A is 8.35, the lower bound for A is 8.25. Then for C we've got 2.5 and 1.5, and for Y, just careful with this one, correct to the nearest 5, which is not always sort of a common rounding value, but here we're going to get 17.5 and 12.5 as our upper and lower bounds. Then the upper bound for P, well actually in this calculation we want the upper bound for A, C and Y, because taking the upper bound is only going to make these, make P bigger. Take those upper bounds, plug them into the formula, and we get a nice round 167 for our upper bound for P. Question 18 is kinematics, so we're going to be using calculus. To get from displacement to velocity, we differentiate. It's a change in displacement over time. Differentiate 6t squared minus 10t plus 6. To get from velocity to acceleration, we differentiate again. We find dv by dt. So differentiate again to get 12t minus 10. We can equate that to 5. It tells us that the acceleration is 5, and solve the equation to find the value of t. Add 10 to both sides, divide both sides by 12, we get t equals 1.25 seconds. Question 19, we can't plug a number in which creates a denominator of 0, so if 2x minus 9 is equal to 0, it's no good, and that happens when x is 2.5, so we can't include 4.5, so we can't include 4.5 in the domain. F of g of 4, we find g of 4, which comes out as negative 5, find f of negative 5 comes out as negative 18. For C, it's an inverse function of a quadratic. The only way to do this is by completing the square and then reverse engineering it. To complete the square, first thing I'm going to do is factorize out 3 and leave the plus 8 alone at the end. Factorize out 3 and then complete the square with y squared minus 4y, replacing it with y minus 2 squared minus 4. And then I'm going to expand things out. So 3 lots of y minus 2 squared is 3y minus 2 squared. 3 times minus 4 is minus 12, and then plus the 8 at the end. Minus 12 plus 8 simplifies to minus 4. Then add 4 and divide by 3. I did that in one go. If you did that separately, that's fine. Then we're square root. I'm going to take the positive square root because it tells me that x is greater than 2 in the question. I'm not going to take the negative square root in this one, and therefore our inverse function is 2 plus the square root of x plus 4 all over 3. Question 20, we want to find the shaded region. So we're going to find the area of the triangle ABC and find the area of the circle, and then subtract the area of the circle from the area of the triangle to get the area of the shaded region. It's an equilateral triangle, it says in the question, so half AB sine C, A and B are both 10, and the angle will be 60 degrees, and so half times 10 times 10 times sine 60 is 25 root 3. For the radius of a circle, I've constructed a little right-angled triangle in the shape. You can see me constructing it there. The angle inside that triangle is going to be 30 degrees. The side length is 5 of the adjacent, and the opposite will be the radius. So tan of 30 will be equal to the radius divided by 5. Or if you prefer, the radius will be equal 5 lots of tan 30. which is equal to 5 root 3 over 3. So the calculation for the shaded area, well, the area of the triangle is 25 root 3, so we're going to subtract and then pi r squared, where r is the radius we've just calculated. I'm using unrounded answers here, which is better. If you used the answer function in your calculator, that's absolutely fine. Either way, that shaded area comes out as 17.1 centimeters squared. Question 21, to find the coordinates of A and B, is the same as asking us to solve these simultaneously. I'm going to take the linear expression, I'm going to make x the subject of the linear expression and substitute that in. If you made y the subject of the linear expression, you'd end up having this sort of horrible fraction, 5 minus x over 2, which you'd then be squaring out, and it would get horrendous. Anyway, substituting x into the nonlinear equation, expanding out the squared brackets, we get a 3-term quadratic equal to 0. It needs to be equal to 0 because we're solving a quadratic here. Factorizes quite nicely. If you completed the square or used the formula, that's absolutely fine too. But the two y values, 6/7 and y equals 2, and those correspond to x being 23/7 and x equals 1, and that gives me the coordinates of the 2 points 1, 2 and 23/7, 6/7. You must have shown clear algebraic working. Question 22, the vectors question. The first two marks are gifts. O to C, well, you can go from O to B and B to C, so there's going to be 4b plus 2a minus 2b, and that's 2a plus 2b. For the vector A to B, I'm going to go from A to O and then O to B, so minus 3a plus 4b for that one. Okay, so part B is the tricky one where we have to find the ratio of A to P to P to B. And we do this by finding the vector A to P in two separate ways. And those two separate ways will look different, however, they will be the same vector. So having A to P calculated in two different ways will allow us to find out essentially what the proportion of A to B is when we're finding A to P. So A to P is a proportion of A to B. I'm going to call that proportion lambda. Lambda is just going to be a fraction, so it's lambda lots of A to B. A to B is minus 3a plus 4b, that's from part A. Expand it out, we get A to P being minus 3 lambda lots of A plus 4 lambda lots of B. The alternative way of getting from A to P is to go from A to O and then go from O to P. Now we don't have the vector O to P, but we do have the vector O to C, and we know that OPC is a straight line, so we could say that O to P is a proportion of O to C. I'm going to call that proportion mu, it's just a different fraction. So A to O is minus 3a plus mu lots of 2a plus 2b, expand out the bracket, minus 3a plus 2 mu a plus 2 mu b. I'm then going to factorise this. I'm going to factorise out a little a. We'll get 2 mu minus 3 lots of little a. I know I'm factorising, but I'll write the vector at the end still because it's a vector. So it's that many lots of little a plus 2 mu lots of little b. And this is where I know that the vectors A to P in two different ways, the number of little a's in both of them will be the same, and the number of little b's in both of them will be the same. So I can essentially equate coefficients. 2 mu minus 3 must be equal to minus 3 lambda, and 2 mu must be equal to 4 lambda. Essentially now we're just solving simultaneous equations to find lambda. 4 lambda minus 3 equals minus 3 lambda. Add 3 lambda to both sides, 7 lambda equals 3, so lambda equals 3/7. So lambda is 3/7 telling us that A to P is 3/7 of the way from A to B. so A to B to B to B, is 3 to 4. Well done if you managed to get that one. Question 23, we've got a frustum. Okay, volume of a cone 1/3 pi r squared h. First calculation I'm going to do is the volume of a large cone, that's including the dotted bit at the top without it having been chopped off. 1/3 pi times 6 squared times 15, and so the volume of the large cone is 180 pi. The volume of the little cone, that little cone is the bit that's being chopped off. I know it's not the one we're trying to calculate here, but it's going to help us. The volume of that little cone is going to be the volume of the larger cone subtract the volume of the frustum. Now it gives us the volume of the frustum in the question, so I can subtract that from 180 pi, which we've just calculated, to find out what the volume of that little cone will be. And it comes out as 288 over 25 lots of pi. So from that we can work out the scale factor of volumes of the little cone and the big cone. Scale factor, so the volume of the little cone, 288 over 25 pi. The volume of the big cone, 180 pi. Those are of course similar shapes. And that gives us, when we simplify it, a scale factor of volume, divide both sides by pi, simplify your fractions, we get 8 to 125. To find the scale factor of lengths, we can cube root both of those, comes out as 2 to 5. And now we have the scale factor of lengths. Well, we know that the ratio is 2 to 5. We've got 6 centimetres as the radius of the larger cone, so the radius of the smaller cone, x, is going to be 6/5 of 2, which comes out as 2.4. Okay, last question on the paper, question 24. Lots of algebra going on here, although for the last question, although it looks quite messy, the question itself, the skills that are involved aren't particularly difficult given it's question 24. First thing I'm going to do, I'm going to see what we can cancel. So it becomes a bit of a factorising festival, factorising the first numerator, factorising the denominator. For the addition of the two fractions, where to add two fractions we need a common denominator. So the first fraction I'm going to multiply the top and bottom by x. Second fraction I'm going to multiply the top and bottom by 3x minus 4. I'm going to leave the right hand side alone for now. For my next line of working, I'm going to do more factorising. So the first fraction, the 5x, I'm going to leave alone. 9x squared minus 16. The difference of two squares is jumping out at us. So 3x plus 4 times 3x minus 4. I'm going to leave the denominator alone. For the addition of the two fractions, well, the numerator will be x plus 3x minus 4, which is 4x minus 4. I'm actually going to factorise that immediately to 4 lots of x minus 1. That's over x times 3x minus 4, and that's equal to 4 lots of x plus 2 over 5x minus 8. I've not touched anything on the right-hand side. Then let's cancel everything that cancels. So I'm just looking, I'm going to cancel x and x there, I'm going to cancel a 3x plus 4 and a 3x plus 4 there, I'm going to cancel x minus 1s, I'm going to cancel 3x minus 4s. I'm actually only left with 5 times 4 in the numerator. So it all simplifies to 20 on the left hand side. On the right hand side, I've still done nothing, so I can now multiply both sides by 5x minus 8, gives us 100x minus 160 equals 4x plus 8. Bring the x's onto the left, the non-x's onto the right, divide both sides by 96, and we get x equals 1.75. Well done if you got that one. Bye.